Hello Tanga, welcome to GullyClassroom. This is the 7th lecture in the chapter Acids, Bases and Salts in CBSE 10th Standard Chemistry Science Book Chapter 2 and Acids, Bases and Salts. This is the 7th lecture taken in English. This is the 7th lecture taken in English. What are you going to teach us in this particular lecture, sir? We are going to look into what is baking soda, how to manufacture baking soda, what are the applications of baking soda. We will also study about how to manufacture washing soda and also what are its properties as well as its uses. Finally, we will study what is water of crystallization. We will study an experiment to analyze water of crystallization, and then we will study about gypsum and plaster of Paris. How to convert gypsum to plaster of Paris and how to convert plaster of Paris into gypsum. That's basically the content that we are going to cover in this particular lecture. Yeah, can we start it? Okay, let us start it. Baking soda. What is baking soda? As we have seen in the last lecture, baking soda is nothing but sodium hydrogen carbonate, or it can also be called as sodium bicarbonate. Baking soda is a mild basic salt. Why is baking soda a mild basic salt? Baking soda is a mild basic salt because Na from basic soda is from NaOH. HCO3 from baking soda is from H2CO3, carbonic acid. Let me repeat myself. The positive ion in the salt baking soda, sodium Na plus, is from NaOH. HCO3 bicarbonate negative ion is from carbonic acid. This is a combination of a strong base and a weak acid. When a strong base combines with the weak acid, we get the basic salt. Here we get the type of salt of the strong component. We get the type of salt of the strong component. Here base is stronger, acid is weaker, so salt is basic in nature. Salt is basic in nature. Yeah, what is carbonic acid? Carbonic acid is simply a mixture of water and carbon dioxide. It is nothing but the soda that we drink from the store. The soda that we drink, Leher soda that we drink from the store is basically H2CO3, weak acid, carbonic acid. Yeah, we can go for the next point. Manufacture of baking soda. How are you going to manufacture baking soda? What are the components of baking soda? NaHCO3. How are you going to obtain HCO3? HCO3 is nothing but water and carbon dioxide. Let me start with water and carbon dioxide. Okay, then I need Na. I am going to get Na from NaCl. Okay, but you do not need chlorine, Cl, in baking soda. So how are you going to remove Cl? I am going to put ammonia. Ammonia has the nature to come take the Cl away. Ammonia has the nature to come and take the Cl away and form ammonium chloride. Ammonia takes the chlorine away to form ammonium chloride. The rest of the components join together to form baking soda or sodium bicarbonate or sodium hydrogen carbonate. So it is a fun reaction. Are you able to understand the underlying concept in this reaction? Yeah? Okay, sir. What is baking soda usually used for? Baking soda is a non-corrosive base. It has very less corrosive property. It is used for making crispy pakoras and for faster cooking. It is used for making crispy pakoras and faster cooking. Sir, what is the chemical reaction that will happen when baking soda is cooked? When baking soda is heated? Let us look at this. When baking soda is heated during cooking. Let me repeat myself. When baking soda is heated during cooking, what is happening? Baking soda is converted into Na2CO3. Sodium hydrogen carbonate is converted to simply sodium carbonate. This hydrogen is sent out Now what is happening, sir? Whenever you are heating carbonate or whenever you are adding acid to a carbonate, you will always get a CO2. So I am going to put a CO2 here. What next, sir? Here there is H and O, hydrogen and oxygen. They will combine to form water. So sodium hydrogen carbonate, when it is heated, forms sodium carbonate plus carbon dioxide plus water. This equation is not balanced. Let me balance this. Here there is 2 sodium. I am going to put a 2 here. I am going to put a 2 here. So yeah, this particular equation right now is balanced. There are there are 2 carbons. There are 6 oxygens. Yes, everything is balanced. Okay, what are the applications of baking soda? Before you go into this particular topic, sir, can you clear a doubt that has occurred to me? Yes, please tell the doubt, Kana. Sir, here you just told that you are going to use baking soda for cooking. You are going to use baking soda for making crispy pakoras and for faster cooking. The chemical reaction associated with the cooking of baking soda produces Na2CO3 or sodium carbonate. Sodium carbonate, as we have learnt in the last lecture, is a bitter base. Let me recall why sodium carbonate is a bitter base. Sodium carbonate is made up of the positive ion Na is made up of NaOH, and the CO3 comes from H2CO3 or carbonic acid. Here NaOH is a strong base, carbonic acid is a weak acid. When a strong base combines with a weak acid, what is the salt formed? The salt repeats the nature of the strong component. The salt repeats the nature of the stronger component. Here the stronger component is base. Hence the salt is also basic in nature. So bases, as we have already seen, B and B. Bases are bitter. Bases are bitter. So Na2CO3 has to be bitter in nature. And because Na2CO3 is bitter in nature, whenever we are using baking soda for cooking or while baking, Na2CO3 or a bitter base will be formed. So what's the big deal? Sir, because a bitter base is formed, bases are bitter, what will happen? Our food will be bitter, we will not be able to eat a bitter food. Oh yeah, so what are we going to do here? In order to neutralize the bitter base that is formed when cooking baking soda. Let me repeat myself. In order to neutralize the bitter base formed while heating or cooking baking soda, we are going to add some mild edible acid to baking soda. We are going to add some mild edible acid to the baking soda. Usually we use tartaric acid. Tartaric acid from tamarind, imli in Hindi. Tartaric acid from tamarind, imli in Hindi. Yeah, so we are going to use mild edible acid, usually tartaric acid, with baking soda NaHCO3, so that this mild edible acid, tartaric acid, will neutralize the bitter base that is formed while cooking baking soda. So baking powder is essentially a combination of baking soda and mild edible acid. Let me repeat myself. Baking powder is essentially a combination of baking soda and mild edible acid. We are using tartaric acid as the mild edible acid to neutralize the bitter base formed when we are heating baking soda. Are you comfortable with this? Yeah, let us go for the next idea. Before we go for the next idea, we have a chemical reaction. For what, sir? What will happen when we are adding an acid to baking soda? What will happen when we are adding an acid to the baking soda? NaHCO3 represents the baking soda. Here H plus represents the hydrogen ion from any acid. Here I can use any acid. I can use HCl, H2SO4 or HNO3. Here the acid used is irrelevant. So when I am putting an acid with baking soda NaHCO3, what is happening? Sir, let me try this. Yeah, try it out. Sir, whenever an acid is added to HCO3, you will always get a CO2 out of it. Okay, let us put a CO2. What next? Sir, NaHCO3 is basic in nature. Baking soda is basic in nature. B. Baking soda is bitter in taste, blue in universal indicator, and baking soda is a good example for a base. Baking soda is a good example for a base. Bases, bitter, blue in universal indicator. Example B, baking soda. So, since baking soda is a base, you are adding it with an acid, obviously neutralization reaction will happen. You will get a water and a salt. What kind of salt? Here there is sodium, so you will obviously get sodium salt of an acid. You will obviously get sodium salt of an acid. Yeah. So that's basically what is happening with this reaction. There is no need to memorize anything. You need to just understand what is happening. So what is the speciality of the CO2? This CO2 produced causes the bread or the cake to rise and become soft and spongy. When we are making cake, initially you will have duff. What is duff, sir? Duff is basically maida or wheat flour that is mixed with water to form a paste, to form a tough paste-like substance. That is basically duff. When we are having duff, what will you do? You will add baking powder, which is a combination of, baking soda and tartaric acid to the duff. And you will heat it. You will put it in a microwave oven and you will heat it. What will be produced? Carbon dioxide will produce. This carbon dioxide will simply get into the duff and push it up. This carbon dioxide will simply get into the duff and push it up, and it will make the duff porous. It will make the duff soft. It will make the duff spongy. The duff will be converted to bread or cake. Are you able to understand how bread or cake is formed? Yeah. Okay, sir. What are the other applications of baking soda? Baking soda is used as antacids. When we have indigestion in our stomach, more acids are secreted. This causes irritation. This excess acid in the stomach needs to be neutralized. We know that baking soda, NaHCO3 or sodium hydrogen carbonate or sodium bicarbonate is a mild basic salt. It is non-corrosive, so we can use it as an antacid. When we put NaHCO3 and HCl together, what will happen? Here you will form NaCl, here you will form NaCl, and also you will get water, you will get H2O. Are you able to understand what is happening? Basically, our which salt? Baking soda is neutralizing the excess hydrochloric acid to form NaCl and water. Okay, sir. What is the last application? Baking soda is used for making soda acid fire extinguishers. What fire extinguishers, sir? Soda acid fire extinguishers. Soda from baking soda, acid from sulfuric acid. So when you put NaHCO3, which is basic in nature, with H2SO4, which is acidic in nature, what will happen? Here this will break into two components. Here this will break into two components. This you will get Na plus over here, you will get SO4 2 minus over here. This Na plus and this SO4 2 minus will combine with each other to form sodium sulfate salt. What will happen next? This is a neutralization reaction, so I will get a water. Also here this is a carbonate. I am adding acid to a carbonate. I have already told you, if you add acid to a carbonate or if you heat carbonate, usually you will get carbon dioxide. So I am going to put a carbon dioxide over here. Are you able to understand this particular reaction? Are you able to understand this particular reaction? Yeah? Yes, sir. Okay, let us balance this. I think it is simple. Na2SO4. There are two sodiums. So I am going to put a 2 here, 2 hydrogens, 4 hydrogens. Okay, let us check over here. Here for 4 hydrogens, I am going to put a 2. Okay, 6. Yeah, I think that's basically it. I think let us check for carbon. 2 carbon. I am going to put a 2 carbon over here. So that's Yeah, I think it is balanced. Let us check oxygen. 4 plus 2 plus 4, 10. So here let us look at oxygen. 6 plus 4, 10. Yeah, that's basically it. We have balanced this particular equation. Balancing equations are a trial and error skill. Let me be very clear. Balancing equations are a trial and error skill. The more equations you balance, you get better at it. But don't worry about it. When learning the first chapter, when you are learning the first chapter from me, I will spend a special session on how to balance the equations. I will spend a special session on how to balance equations with confidence. Yeah? Okay, that's basically the applications of baking soda. What is the next thing? Next thing is washing soda. What is washing soda? Washing soda is Na2CO3.10H2O. Sir, wait a second. But we have already seen that we can manufacture Na2CO3 or sodium carbonate from NaHCO3 or sodium hydrogen carbonate by simply heating it. Yes. By heating baking soda or NaHCO3, I get Na2CO3 or washing soda. Baking soda can be heated to give Na2CO3 or sodium carbonate. But sodium carbonate alone is not washing soda. What must you do? You must take Na2CO3 or sodium carbonate, add 10 molecules of water. The Na2CO3 will pull this 10 molecules of water towards itself and form water of crystallization. Each and every molecule of Na2CO3 holds together 10 molecules of water. Each and every molecule of Na2CO3 sodium carbonate holds together 10 molecules of water. So this is how washing soda must be manufactured. So if they are asking for the manufacture of washing soda, how am I supposed to write, sir? First, you will write this particular reaction. For the manufacturing of washing soda, you need to first write this particular reaction. Heating of baking soda gives sodium carbonate, and sodium carbonate is combined with the 10 molecules of water. You get Na2CO3.10H2O. Are you comfortable with this? How I am manufacturing washing soda or Na2CO3.10H2O? Yeah, washing soda is a white crystalline solid. It is alkaline in nature. What is alkaline? Alkaline means it is a base that can be dissolved in water. It is usually slippery in nature. What are the uses of washing soda, sir? Let us look at it. Washing soda is used in glass, soap and paper industry. It is used in the manufacture of sodium compounds like borax. Borax is a set of synthetic compounds that have a variety of applications in chemistry. Yeah, it's a very important compound. So, washing soda Na2CO3.10H2O is used in the manufacture of sodium compounds like borax. Also, washing soda can be used to remove permanent hardness of water. First, what is permanent hardness of water? Sometimes water will contain calcium and magnesium ions. These calcium and magnesium ions do not allow soap to function well. When you are washing your clothes in hard water, the calcium and magnesium ions, Ca2 plus and Mg2 plus ions present in hard water stops the foaming of soap. The soap will not wash well. So what are we supposed to do, sir? You can add washing soda. Washing soda removes the permanent hardness of water. Washing soda removes the permanent hardness of water. You will learn about the difference between detergents and soap, hard water and soft water in more depth and in a more illustrative way in the chapter carbon and its compounds. In the chapter carbon and its compounds towards the end. In the unit carbon and its compounds towards the end, we will learn more about how washing soda removes permanent hardness of water. Yeah, it's a very important application. In fact, a lot of questions can be asked like Which compound is used for removing the permanent hardness of water? We are always using washing soda or Na2CO3 dot 10 H2O for removing the permanent hardness of water. Also, washing soda is used as a cleaning agent for domestic purposes. It is used as a cleaning agent for domestic purposes. Okay, sir. Now, can we go for learning water of crystallization? Definitely, Kana. Please come. Water of crystallization. What is water of crystallization? Certain salts, what do? They automatically absorb water even as moisture from the atmosphere. Certain salts automatically absorb water even as moisture from the atmosphere. So, how many number of water molecules do each and every molecule of salt hold on to? Some specific number. For example, here in washing soda, we saw that each and every molecule of Na2CO3 sodium carbonate holds on to 10 molecules of water. Similarly, CuSO4 copper sulfate holds on to 5 water molecules. So, how are we supposed to define water of crystallization? We can define water of crystallization as fixed number of water molecules present in one formula unit of a salt. Fixed number of water molecules present where, sir? In one formula unit of a salt. These salts are called as hydrated salts. Sir, if salts that have water molecules are called as hydrated salts, what is the name for salts that do not have any water molecules? They are called as anhydrous salts. Salts that do not have any water molecules are called as anhydrous salts. Okay, sir. So, I am comfortable with the idea of water of crystallization. Can you just give me a couple of examples? Sure. Come on, Tangam. Here, let us look at examples. CuSO4, copper sulfate, dot 5 H2O. CuSO4, copper sulfate, dot 5 H2O is blue vitriol. Blue vitriol is obviously, as the name indicates, blue in color. Okay, sir. What about FeSO4? Ferrous sulfate. Ferrous sulfate holds on to, each and every molecule of ferrous sulfate holds on to 7 molecules of water. FeSO4 dot 7 H2O. It forms green vitriol. As the name indicates, it is green in color. What about ZnSO4, sir? ZnSO4 or zinc sulfate holds on to 7 water molecules. ZnSO4 dot 7 H2O. It is white in color, so called as white vitriol. Also CoSO4, cobalt sulfate, also holds on to 7 molecules of water. It is called as red vitriol. So it is obviously red in color. It is obviously red in color. Sir, in each and every name, vitriol is repeated. What is vitriol? Oil of vitriol or spirit of vitriol is the very old name for sulfuric acid. Spirit of vitriol or oil of vitriol is an old name for sulfuric acid. Here, from sulfuric acid H2SO4, we are getting SO4 component of the salts. So, we are naming them blue vitriol, green vitriol, white vitriol and red vitriol. Are you comfortable with the analysis? Okay, sir. Sir, how am I supposed to prove that these particular salts contain water? Can you give me an experiment? Absolutely, Tanga. Come on. First, let us take copper sulfate. Some copper sulfate which is blue in color because it contains 5 molecules of water of crystallization for each and every molecule of CuSO4 present in it. It is blue in color. It is taken in a test tube. Then you are heating the test tube. When you are heating the test tube, the water molecules present in the salt will become vapor. What will happen to the color of the salt, sir? The color of the salt is primarily due to the water of crystallization molecules present. So, when CuSO4 due to the heat given loses its water of crystallization, it becomes colorless. Okay, sir. Let us say I am stopping heating. Now what will happen? Once the test tube is stopping heating, once you have stopped the test tube from heating, Once you have allowed the test tube to cool down, slowly the CuSO4 molecules will absorb water molecules from the moisture in the air. This CuSO4 molecules in the test tube will absorb water molecules from the moisture in the air, and they will go back to the hydrated form, and they will once they have cooled totally, they will become blue in color by absorbing water molecules from the air. By doing this experiment, you can show that these are colored salts, and the color of the salts is due to water of crystallization. The color of the salts are due to water of crystallization. Are you comfortable with this? Let us go to the last topic of this particular lecture, Plaster of Paris. Sir, what is Plaster of Paris? Plaster of Paris is a very particular compound that is usually found near Paris, in and around Paris. This particular compound was used a lot. This particular compound was in fact found a lot. So it is called as Plaster of Paris. Plaster of Paris is obtained by heating gypsum at 373 Kelvin or 100 degrees centigrade. Okay, here CaSO4.2H2O is gypsum. What is the formula for gypsum? CaSO4.2H2O. Sir, CaSO4.2H2O. Common name is gypsum. What is its chemical name, sir? Chemical name is given as calcium sulfate dihydrate. Let me repeat myself. Gypsum, chemical name is given as calcium sulfate dihydrate. So when I am heating this to 373 Kelvin, it loses 1.5 molecules of water. It loses 1.5 molecules of water, and it forms CaSO4.2H2O. Here gypsum has lost exactly 1.5 molecules of water. CaSO4.2H2O is Plaster of Paris. Plaster of Paris chemical name is calcium sulfate hemihydrate. You will represent half with the word hemi. So the chemical name of Plaster of Paris is calcium sulfate hemihydrate. Okay, sir. What is the nature of Plaster of Paris? Plaster of Paris is usually a white powder. Let us say you are again taking Plaster of Paris and adding water to it. What are you doing? You are adding water to Plaster of Paris. What will happen? Each and every molecule of Plaster of Paris, calcium sulfate hemihydrate, will take 1.5 molecules of water. Will take back 1.5 molecules of water and form calcium sulfate dihydrate or gypsum, which is a hard and a solid mass. On mixing with water once again, Plaster of Paris forms gypsum. If you heat to 373 Kelvin or 100 degrees centigrade, what will happen? Calcium sulfate dihydrate will form Plaster of Paris. If you heat gypsum, you get Plaster of Paris. If you add water to Plaster of Paris, you get back gypsum as a hard and a solid mass. Are you able to understand what is happening? This is basically the end of this particular lecture. This lecture is very, very important. I have given all the repeated questions for the last 10 years. At the end of this lecture, go through them, try to understand them, analyze how to answer them. These will be the questions that come in the board exam. We can get awesome marks. Hope you guys enjoyed this lecture. Hope you guys enjoyed listening to this lecture as much as I enjoyed taking the classes. I am having so much fun teaching to you guys. Cheers and thank you. Hope to meet you guys in the next lecture. Obviously, if you like our channel, subscribe to us, click the bell icon, like our videos, recommend our videos to your friends, promote our videos and our channel in social media. We will have so much fun learning chemistry together in a very, very analytical fashion with nothing to memorize and understanding every aspect of what is happening. Yeah, cheers and thank you. Cheers and thank you. Bye, Dakana. Bye, bye, bye.